All right. Center of mass. This is how to find the center of mass. This is actually a Physics 1 thing now. They moved it down to Physics 1 this year. So this might be the last year that we teach it as in depth in Physics C because it is now a Physics 1 thing. But the center of mass of like a rigid object is the point where an object um, balances if placed on a fulcrum. So what I mean by that is if you have, for example, an object, okay, and you were to maybe like I guess like we could take my pen for example, or I can find the center of mass of my pen by shifting my finger as a fulcrum to the point where I can balance my pen on my finger. And let's see, that seems to be about my center of mass, right? Center of mass is where you can kind of balance an object. Center of mass is also where an object wants to rotate around. So you notice that when I found the center of mass of my pen, right, when I didn't have it quite there, it wanted to rotate about that center of mass. Okay, it's also the center of mass is also um, what makes the parabola in projectile motion. Okay, um, so yeah, there's that, right? It's important to note, like I'm about to give you a formula for how to find center of mass, but the center of mass is the weighted average of the positions of all the particles. So if you have a system of particles, the weighted average, what that means is that the average is weighted by the mass of the particles. So what that means is that the mass of the particle on has a weight effect on it. So if you have a particle with a lot of mass right here and a particle with not a lot of mass over here, then the center of mass is going to be more towards the heavier particle because it goes by the weighted average, right? And you can think of it conceptually like a seesaw, right? Somebody who has a lot of mass doesn't need to sit very far on the seesaw to balance out somebody who is really light, right? So a good equation for this is going to be x sub cm, that's what we call center of mass position, would be equal to the sum of mass I times position I over the sum of all masses. Okay, and what this I is like an index, right? So you would do like mass 1, position 1, mass 2, position 2, and so on. You'll see the example here in a second. Okay, this part on the top, we call this the first moment of mass. Okay, that's more of a formal definition of what it is. And this part down here is just the total mass. Okay, so you're just adding up all of the masses together in the system to get the total mass of the system. Okay. But that first part on the top, we call it the first moment of mass. You don't really need to know that that's what it's called. It's kind of just a more proper definition. So if you like Google it or something, you know what that is. Okay. Okay. Mark the center of the mass as shown in the diagram. I'm going to show you two ways to do it because you're gonna be shocked, right? Notice that I don't give you numbers on the scale. Okay, you actually would have to fill in the numbers here, and you can decide whatever system you want. Do you want to start at 0 on the left, or do you want to start at -10? Do you want to make this part in the middle 0, or you want to make this part 0? It can entirely up to you. Heck, if you want to make this 0 all the way here on the right side, you could do that too. It'd be perfectly fine. So I'm going to do -10, -5, 0, 5, and 10 up here, and then down here on the bottom, I'm going to do 0, 5, 10, 15, and 20. Okay, so I'm going to solve it two different ways, one in purple, one in red, just to show you that the answer you get is going to be the same. Okay, you're going to get different numbers, but the actual location is the same. Okay, so using the purple numbers, okay, I've got a 3 kilogram times its position at -10. Okay, and I need to add the 2 kilogram at its position -2. Okay, and then I need to add the 1 kilogram at its position 4, and then I need to add the 4 kilogram at its position 10. Okay, and then I take the sum of all of the masses. So I've got 3 plus 2 plus 1 plus 4. And when you punch that into your calculator, you actually end up getting 10 over 10, which is 1. Okay, so the center of mass position for the purple numbers is 1. Okay, so it would be on the 1 spot, which is right here. So I'm going to label this right here, purple center of mass. Okay, I'm writing it in purple so that you know. Okay, now let's see what we get if we use the red number system. Okay, what are we going to get if we use the red number system? Okay, well, let's see. We've got the position of the center of mass is equal to, now I have to change the numbers, okay? So instead of using -10, this is going to be 0, okay? Um, this is 2 kilograms at -2, okay? This is 1 kilogram at 4, and then this is 4 kilograms at 20. So then the total mass we already found earlier is 10, okay? You should end up getting, in this case, you're actually going to get a different number. You get 110 over 10, which is 11. So this means that the position of center of mass with the red numbers is 11, okay? And if you take a look at the red numbers, you're 1 after 10. Hey, wait a minute. That's the exact same spot. We just marked that. Okay, so you notice that you get the same center of mass no matter how you number it. No matter how you spin it, you get the same center of mass. Okay, so you get to really pick the system here. Okay, and you'll see when we do 2 dimensions, you can do the exact same thing if you so wish. Okay, all right, well, there's that. Okay, that's the first section. There's 2 more, I think 3 more sections of center of mass. Okay,